All right, as we continue our lesson on proportionality, let's look at two special theorems that go with proportions and triangles. One of them is called the side splitter theorem or the triangle proportionality theorem, and one of them is the angle bisector theorem. So the triangle proportionality theorem, the side splitter theorem, says that if a line is parallel, so if RS is parallel to XY, if a line is parallel to the sides, to one side of the triangle, and intersects the other two sides, so RS cuts through QX and QY, then it divides those sides, QX and QY, proportionally. So if RS is parallel to XY, then XR over RQ is equal to YS over QS. Now, notice that QR and QS are the sides of that small big triangle, that small triangle on top is what I was trying to get to, QRS. But RX and SY are parts of the sides of QX and QY. Okay? So it is important to note that, okay? We are not proportional with the bottoms, okay? RS and XY are not proportional with these sides in their parts, okay? So you kind of want to look at it like part and whole. So the side splitters are proportional. Now, that also can extend to any number of parallel lines, that if you have 3 or more parallel lines that cut transversals, then they cut the transversals proportionally. So that means that if line A, line B, and line C are parallel to each other, then AB over BC is equal to WX over XY. You can also use AC. So you could also say, excuse me, that it, like AB over BC, or you could say AB over AC. You could say AB over AC is equal to WX over WY. Part, whole, part, whole. So any of those pieces are proportional. Now, this only applies to the sides that were split. So these sides were split. This side was split. RS and XY were not split. They were doing the splitting. So the proportionality only applies to the sides that were split. If you want to find RS or XY, then you have to go back to what we did the other day, where you do the whole side and the whole side and the whole bottom and the whole bottom, okay? You cannot, if you need RS and XY, you cannot use this theorem. It doesn't work. It's only for the sides that were split, hence the name the side splitter theorem. So let's look at it in some problems. HL is parallel to EF, which means HL and EF split EG and FG, the sides. EH is 9, HG is 21, FL is 6, find LG and FG. So I'm going to put an X right there because it's the one piece that's missing. Because they were split, okay, because these two sides, EF and HL, because those split these two sides, they are proportional. So I can set it up, 9 over 21 equals 6 over X, and use the cross multiplication theorem, okay? Sorry, excuse me. So if you do that, then you can cross multiply 9X and then equal to 21 times 6, and you get that LG is 14. And then FG is the whole side, part plus part, so 6 plus 14 is equal to 20. Now, just on a side note, just to remind you of how we have done this in the past, you can still use this broken into two triangles. You can still do 21 over 30 is equal to X over X plus 6. That is still totally a viable way to do this problem with proportions the way that we used it before. So if you're afraid you're going to get confused, then just keep doing it the way that we've been doing it and don't worry about it, okay? But this will work as long as you're dealing with the sides that are split. If I needed EF or HL, you can't use that. You can't use side splitter You have to go back to using the whole triangles. Okay, with this one, now this is why this one makes this, like the side splitter makes it easy, because before we would have done 12 over x plus 1 plus 12, and then equals 9 over 9 plus x. But because of the side splitter theorem, because these two lines, these parallel lines, are like arrows that split those two sides, we can set it up 12 over x plus 1 is equal to 9 over x. Again, I'm not looking for KL or PN. Cross multiply, 12 times x is 12x equals 9 times, remember that's an expression, 9 times x plus 1. Don't forget to distribute that. You get 12x is equal to 9x plus 9. Subtract the 9x from both sides. Collect your like terms. 3x is equal to 9. So, 9, I got ahead of myself. So x is equal to 3. Now, just so you can see it, that means that MK is 12. That means that KP is 3 plus 1, which is 4. And ML is 9, and LN is 3, is x, which is 3. Look at this. So 12 over 4 is equal to 9 over 3. That's true. Okay, that's what it's saying, is that it's proportional. Okay, so let's take a look at this problem, real world problem. 3 campsites are shown in the diagram A, B, and C. What is the length of site A along the river? So what I am looking for is, I'm looking for this piece right here. So this goes to that corollary. Because I have multiple parallel lines, each of these pieces is proportional to the other pieces. So the way that you can set it up, there's a lot of different ways you can set it up. But one way would be, let's call this x. So we can do x over 8 equals 9 over 7.2. Just go in the same order. Whatever you do, go in the same order. You could also do x over 9 equals 8 over 7.2. That also works. Okay, cross multiply, and you get that x is equal to 10 yards. So x is equal to 10 yards. Then what is the length of side C along the road? Same thing, side C, we'll call this y just for a different variable. We want this side right here along the road, because here's the road. Well, you can set it up in several different ways, but you can do 8 over 6.4. You could do 10 over 6.4. I just don't like to use answers that I found, just in case. 8 over 6.4 is equal to, same pieces on the other side, 7.2 over y. Cross multiply, you get that y is equal to 5.76 yards. You could also, just so you know, you could also set it up 8 over 7.2 equals 6.4 over y. So it's this over this, this over this. So you can set it up that same way. Notice you're still multiplying 6.4 times 7.2. That's the side splitter theorem. When you are dealing with parallel lines that split through lines, it splits them proportionally. That's the side splitter theorem. Now we have this triangle angle bisector theorem. The triangle angle bisector theorem says that if you have an angle bisector, which this AD is the angle bisector, it cuts this angle right here into 2 congruent pieces, so it is bisected. It divides the opposite side, so this bisector is cutting this side into 2 segments that are proportional to each other. So if AD bisects angle BAC, this angle right here, then CD over BD is equal to CA over BA. You could also say AC, this side, over CD, AC over CD is equal to AB over DB. That's kind of my preference, because then it's kind of already set up for you, and you just use the 2 sides of the one triangle and the 2 sides of the other triangle, and you can set up that proportion. Now, I like that because, like I said, this one's already set up. Look, you have 9 and 24 belong to this triangle, so 9 over 24 equals x and 18. Okay, so you can say 9 over 24 is equal to x over 18. Okay, you can also say 9 over x is equal to 24 over 18. Either one, 9 over x equals 24 over 18. It doesn't matter what order you go in, just pick an order, pick one way and stay with it. Solve it by cross multiplication. You do 9 times 18 divided by 24, and you get that x is 6.75. Now look at it, it makes sense. 9 and 24 are 24 is longer than 18, so 9 should be longer than whatever x is, and x is 6.75. Now the problem with number 5 is that you're missing a piece. We're missing this piece right here. So I have the whole thing, but all I know is that this angle bisector has split this one whole side proportionally, which means I need this piece. So I need to call it something. I know from here to here is x, and I know the whole thing is 15, so we're just going to rename it, and we're going to say, well, this piece would be 15 minus x. For instance, if x was 10, then I would know that this is 15 minus 10. It's 5. So when you don't know what to do, put real numbers in it so that you can see what the math does, and then you can follow the pattern and put the variable in. So now we just follow our same pattern for our triangle angle bisector. When you see this angle bisector, so this right here, that's your clue that you're going to work this way. I like it. It's already set up right here, nice and pretty. 15 minus x over 20 is equal to x over 10. Again, you can also do 15 minus x over x, similar pieces, so this, and then go back to the left equals 20 over 10. Either way, you get the same answer. Okay, so when you cross multiply, now look, you can also do this like that. I could go ahead and simplify. That's 2. If you multiply that x by both sides, then you get 15 minus x is equal to 2x. Collect your like terms. 3x is equal to 15, or x is equal to 5. If you do this side, don't forget it's 10 times 15 minus x is equal to 20x. Either way, you'll get that x is 5. So x is 5, which means that this piece is 10. I know it's not drawn to scale, but that's okay. We do know that this is longer than this, so this has to be longer than this, okay? Even though it's not drawn to scale, that's okay. So we have two theorems now. We have the triangle angle bisector theorem that says the angle bisector bisects these proportionally, and then we have the side splitter, or the triangle proportionality theorem, that says that if you have parallel lines cutting through the sides of a triangle, that the sides that were cut were split proportionally.